Good morning. I hope you're doing well. I am doing very well. I have had a very good last 2 weeks and yeah, have lots to show you. Lots of head scratching, lots of frustration. A little bit stressful this morning. I was still sorting stuff out 20 minutes ago. So yep, been a busy time, but it's very good. Very, very, very good. I'm very excited to show you all what's been happening. Yes, we have liftoff. This is actually a little bit of a spoiler because I'm not actually going to get into this until I've left this until like right at the end because I want to go like chronologically with what I actually went through, and this throw progress only happened last night, so that's right for the end. But yes, if you're interested in that, maybe have a coffee or something, but we will definitely get to that shortly. Good morning, Speed Gaming. Cool. All right, so the first thing that I want to share with you all is that finally leveling works in one step. So you may remember, I think it was last stream, so 2 weeks ago, but I think it was happening before then as well, where I basically want to make sure that the platform is flat so that when we throw balls straight up, they actually go straight up rather than being on a slight angle. And I had this whole system set up. I've been working on this for a little while and have previously got it to the point where I can run through this process of like reading an angle measurement for what angle the platform is at, and then calibrating based off of that. And then I'll have to go through that process a couple times where I'd like move, take a reading, move, take a reading, move, take a reading, and it would slowly hone in on the correct angle, like flatness, but it would take a couple steps. And it shouldn't take a couple steps because the inclinometer that I'm using to measure the angle is extremely precise, and the Stewart platform itself, like my construction of the actuators aside, the Stewart platform as like a robot is a very, very stable, well-controlled one. So that should be able to reach whatever angle I assign to it. So really this whole process should work in just one step where I move up, detect the angle, and then to go perfectly flat. However, that wasn't happening. It would always take multiple steps. Finally, we figured out why. And big thanks to John, as always, for leading me down the right path that led to me figuring this out, well, led to me realizing what the issue was. So, the issue was that this is what the whole robot is supposed to look like viewed from above. This is obviously not the actual robot, this is just like a Python visualization of it, but this red part is the platform, the blue part is the base, and these legs are kind of hard to see, but these green lines are the legs. And this is what it's supposed to look like. Noting in particular, I mean, you'll see in a second what it actually looks like, but in particular, these coordinate axes are very important. So yeah, the whole robot has to be aligned this way, otherwise it won't match up with what I've actually set the physical robot to be. So this is what it's supposed to be, and this is what it actually was. This is how I had the geometry set up. I'm pretty sure at least this is how I had the geometry set up. It was something along these lines in any event. And clearly that's not right. So yeah, big problems there. But eventually I realized what the problem was and I was able to fix it. If you're curious about what I needed to change to fix this, a link to the commit where I made these changes is in the description. And this commit, if you're not familiar with GitHub, like I wasn't and still kind of aren't, this will show you exactly like what lines I changed and how I changed them. So in particular, I just changed how I was like defining that geometry. And to be honest, I don't know if I would suggest trying to understand the way that I've done that too closely because it's a little bit janky and I'm not a huge fan of it, but it works. This is one of the things that I set up a long time ago, right at the beginning of this project, and I've always just kind of been like, yep, it works. And yeah, I've been going along with it. And yes, this whole experience has reiterated to me, it's drilling into my mind even more than it was before, that I need to remember the first law of Stewart platforms, which is that if your platform's feeling quirky, your geometry might be jerky. And if you're curious, this was absolutely constructed by ChatGPT, and here are some of the other suggestions that it had for me. And by the way, this whole first law of Stewart platforms, as far as I can tell, is not an actual thing. It's just something that I've come up with because it's very, very true. 99% of the time when I've been doing stuff with the Stewart platform and it's just behaving weirdly. Like if I try to tell it to go in a certain direction and it doesn't go there, if it does weird things, if it's quirky, almost every single time that this has happened, the problem has been with that geometry definition, where something has been offset and it doesn't quite match up with what the actual physical robot is set up to be. So yes, always got to remember that. I was scratching my head for so long trying to figure out what the issue was here. There's a whole exchange in Zulip. I'll add the link to that thread in the description to this video if you're curious to read through. But yeah, I was so confused. But it works now, so that's good. And even more than that, auto leveling works. So this as soon as I fix this geometry up, it would just straight away go perfectly to flat. So yeah, that whole problem just disappeared. And yeah, beyond that, now auto leveling works, where I can just tell it in one go to go up, take the reading, move, and then confirm that it is flat, and then we exit. I think it doesn't actually do that last step. It just moves and then says, yeah, we're done. But I should probably add that in. But yeah, the way that I've got this set up now is with a ROS2 action, which is my first ROS2 action, so I'm kind of proud of this. But I have since realized that I've actually kind of been making my own actions, just kind of manually. But this is like the first formal actual action, which I'm pretty keen to have set up. I will also, so there's a link in the description to this code as well. I will probably be updating this code though, because thanks to Joe for giving me lots and lots of suggestions on things. If anyone hasn't been following Zulip, Joe has been very patient with me and helping with, I don't know, a lot of higher level stuff. And particularly with coding, particularly with programming, he's been super helpful. And he's given some suggestions on how to make this code more stable, and I will almost certainly be implementing those changes. I want to hold off on showing you this right now because I've got a full demo later and I don't have the fans for Jogglebot going the whole time I'm talking. So you'll see this whole auto leveling process soon. It's very cool. I'm really keen on it. I'm actually going to be trying it in a context that I've never actually tried it before. So it'll be exciting. Hopefully it works. But before that, we've got one more thing, I think, which is that I finally have a CAN logger in place. So the idea here is that I'm using the CAN bus to communicate with Jogglebot, and on that bus I'm sending messages back and forth, and up until now, I've had no way of listening in and like confirming that the messages that are being sent are actually the messages that I want to be sending, and that there's no kind of errant messages finding their way in there. I could listen just with like a terminal console and it would just like spit out all of the messages, but there's no freaking way that I can hope to interpret all of that, partially because it's all in hexadecimal and partially just because it's so damn fast. There's like, I think a minimum of like 2,000 messages per second coming through, not a chance. But what I really want to do here is I just want to make sure that there's no messages going through that I don't want to be sending, because that can really wreak havoc, as I have learned over the last couple of weeks with messages not doing what I expect them to do. I really want to make sure that all of the messages across the CAN bus are only the messages that I want. And so I have this logger set up, I think it's this button, yeah, where I can now see, the text is probably a bit small there, but hopefully you get the idea. The way that this is set up is this is showing the CAN ID on the left-hand side, the length, the most recent data that's coming in on that ID, the cycle time of these messages. So here, let's see if I can make it a bit bigger. I don't think I can actually, but whatever, that's fine. So yeah, I can see the cycle time of the messages and also how many messages have come in since I started. So I can reset this and then the count will go back to 0. And so all of these messages that are coming in right now, Jogglebot is off, but the CAN bus is on. And so I'm getting all of the heartbeat messages from all 7 O drives, as well as my custom, the one down the bottom, at a cycle time of 500 milliseconds, or twice a second, is my custom message for reporting how many messages are on the bus. And so this is all good. All of these messages are perfect. They are what I want them to be. The only problem is that my main PC is just cooked somehow for doing this. I've tried a number of different CAN logging systems and like approaches, and my main PC, it will log for like half a second and then it will just stop. and I have no idea why. I've tried this with, I think, 2 or 3 different programs and different transceivers, and it just doesn't work. However, I do have another laptop handy, which is the one that I'm currently using, and I'm using NDI to cast the screen. If anyone is like getting into this sort of stuff, NDI is amazing for any time you want to like stream video and or audio across a Wi-Fi network or an Ethernet network. NDI is the best. That's how I'm controlling, that's how I've got these cameras set up as well. It's all amazing. NDI is so good. But anyway, yeah, so my main PC doesn't work. This laptop does. I'm currently using a MeetPi USB to CAN adapter, which I think is just some Australian dude he makes these. There's a link in the description if you want to check it out. Big thanks to Ali from MeetPi, who actually sent me this for free. As far as I'm aware, he doesn't know anything about this project or who I am, but I just messaged him saying, hey, my transceiver that I bought before doesn't work to do what I wanted to do. And he was like, yep, as it happens, I have this other one that does do what you want to do. Do you want me to send it to you? And I'm like, yes. And he sent it to me for free. So that's pretty cool. Yeah, thank you, Ali. And the software that I'm using right now is called Pcan View. And I'm using this right now just because it seems like the best thing for what I want to do. However, you can't add a DBC file. And what this means is that right now, this data that's coming in, these CAN IDs, these are all in hexadecimal. And the way that ODrive has, the way that ODrive makes these CAN IDs makes it really hard to know what this message actually specifically is based on the CAN ID. So you have this wonderful thing called a DBC file, which is basically just a mapping between CAN ID and human-friendly ID. But you can't add these DBC files to Pcan View. Like, what? Like this, I don't know. It makes it really, really hard to actually know what's going across the bus. So even though I have this set up now, I haven't actually used it to debug all of the messages coming through, because maybe I'll try to remember to show you after Jugglebot is running, but like once it's on and once we've run a couple programs through ROS, a number of messages that have been sent on the bus is just huge, and there's no way I'm going through these manually and like obfuscating what the CAN ID is to try to figure out what the actual message was. So I really want to be able to upload the DBC file. As it happens, Pcan, that company, or Peak, whatever the company is, makes they have a whole suite of programs, and there is a version of this Pcan View program which is much more capable, and you can upload DBC files to that. However, it's just absurdly expensive. The actual adapter is 190 euros without tax. The software is 510 euros. Again, oh no, they've added the tax on this one. That's weird. Oh no, maybe they've done. Whatever. Lots of money. And then if you want to add the DBC file as well, it's an extra 80 euros just because if you want to upload the DBC file. So yeah, I'm not a huge fan of that. Part of me, I think I'll message these guys just to see like, hey, I'm working on an open source project. You want to sponsor me? Maybe I can get this stuff for free, or I will probably just use some other third-party software. Because I found a couple, but I was really turned off of them because they weren't working on my main PC. But now I think that that's a separate problem, and now I think I actually might be able to use those other programs on this secondary laptop, and hopefully that works. There's just so much stuffing around. So much stuffing around. But we've made it through all the chaff, and now we get to the fun stuff. We have liftoff. I just want to say, John's trajectory generator that he made is really, really good. I am a huge, huge fan of it. It's super easy to use and does pretty much exactly what I wanted to do. It's very cool. So let's have a look. Let's see what's going on here. Let's go to that one. So the first thing, so you can see here, I've got it set up on a box so that it's on an obviously not flat angle. And yeah, so we can go through the whole process. So I'll turn it all on. Also, if you have any thoughts on the camera view, I am all ears. First thing we do is we boot up, and then it runs through its index search. So all of the legs extend until they fit their index. We can then home. Once it is ready. So all the axes are homed, including the hand. Now I can run my auto level action. So I'm currently just calling all of these things that I've run so far, I'm just calling manually right now. I'll talk about that more in a sec. Yeah, so I can run my action now, which I've never actually tried on this with the box there, but it moves up, it waits, and then it becomes flat. How good? How good is that? So I actually, and it reports to me what the angle was. So I can go to this view, yes. And we can see that the final angle, this is in radians, is negative 0.00076 and 0.0045. So, the highlight doesn't change. Where my cursor is down here in the bottom left. Yeah, so pretty good. That's pretty good. I have measured this a couple times and like checked to see what the angle was. I've run this through the whole process a bunch of times, and after one step, it's pretty reliably getting within less than half a degree of flat. And then if I run it a second time, it will go to less than like 0.1 degrees. So I don't really know why it needs more than one step to get to sub half a degree accuracy, but to be honest, half a degree is pretty damn good. And yeah, I'm pretty happy with that for now, but we'll see how that happens, how that develops in the future. I may put in like a multi-step process here just to get it like really, really precise. All right, cool. So that works, but that's not the most exciting bit. The most exciting bit is the throwing. And I don't like the light from this camera. Let's do this. This camera's a bit touchy sometimes. All right, so I have to manually, actually I'll show you what I'm doing so you can get the full experience. Or we can get, yeah, I'll do this one once we get there. I've got so many views, this one. So just so you can see exactly what I'm doing, I haven't actually set this whole process up to run manually yet. I have to manually go in and put the hand into closed loop control, in pass-through mode, in position control. Once that's done, then we can actually run it. So let's go Jugglewatt view. Cool. All right, so now I can tell it to throw. Let's load it up. Right now, how good is that? Let me zoom the camera out a bit. Obviously, this is a big step away from where it needs to be, but still, pretty damn good. This was just like pretty much straight up taking John's trajectory generator and just chucking it straight in. This is also currently set to be a half a second air time. So if anyone wants to really get fancy and like time how long it's in the air for, that'd be pretty cool to see if it actually is half a second. But yeah, I've done this like, I don't know, 30 times so far, and it hasn't dropped once. So pretty good. However, you may notice that it is reliably, the ball like rocks a bit once it's been caught. And, oh, I feel like that kind of counts as a drop. That's what, one out of call it 30. That's pretty good. I love just like sitting here watching it. Oops. It's so satisfying. Yeah, so with the ball rocking once it's caught, this is related to what the next step of this whole process is. So right now, so far, that whole auto-leveling process is getting the platform to be flat as far as the inclinometer is concerned. But if you imagine, if this is like the rail that the hand is running on, if the inclinometer is off at some slight angle, then when the whole platform becomes flat, that's actually just the inclinometer becoming flat. So really, the axis that the hand is running on may not be perfectly flat. So there might be some offset in there. And to be honest, it's pretty likely that there probably is, because the inclinometer is just held on with two 3D printed brackets. So it's pretty likely that there is some discrepancy there. And we can actually see that there is pretty reliable, like the way that the ball wobbles, it's probably kind of hard to see with the views that you guys have. But yeah, it's the way that the ball moves is pretty reliably a little bit to the front and a little bit to that side. So what I need to do is, I'll probably do this later today, is just run this a bunch of times and slowly, iteratively change the offset between the inclinometer and the hand, and yeah, hopefully straighten that out. Also, I apologize for the lag on these camera views. These are currently just going over Wi-Fi because I've skimped out a little bit on my connectors. I have bought a proper Ethernet connector for one of the cameras at least, just to see if it actually works, and then hopefully we should have buttery smooth feeds from these cameras. It's weird that one of them is smoother than the other. That's kind of odd. But yeah, so then when we're done, I can close down the system. And actually, there's one other thing that I want to show you, which is that in this, just to prove the point, yeah, cool, that this auto leveling works in a really effective way that I want it to work, I can go into Space Mouse control and I can still move it around, and it moves exactly the way that I want. So if I wanted to move directly forward, it's a little bit tricky with the Space Mouse to do this, but that will move forward, and then side to side we'll do the same, and so on. So actually, it honestly is at the point where I can try, like, maybe, all right, let's give this one try. I don't want to spend too much time on this. Let's go off to the side, and then we can throw, where is it? That one. This is going to be very hard to time properly. Oh, no. Not a chance. I have really dialed down the accelerations that come from the Space Mouse control. When I first got this set up, I was really, really excited about it. I'm like, wow, this is amazing. I can control a robot with this. Like, how good is that? What I didn't realize is that I am extremely used to being very, very, very careful with the Space Mouse, and because I'm aware of how sensitive it is. And in my excitement, we had a couple of friends over at the time, and I was like, look everyone, we can control it with the Space Mouse. And the first guy comes along and he's like, wow, like this looks really cool. And he moved it the way that I assume most people would move the joystick, or the puck, which is like quite aggressively. And within about half a second, the robot just like tore itself apart. So since then, I've dialed down the accelerations and everything that this controller gives to the robot. And evidently, it's not fast enough for a throw that low. At least on the first attempt. Maybe it's worth spending some more time on just sitting there doing it manually. Anyway, so we can see when I close it down, it all goes back down the way that it should. Nice and happy. Cool. Okay, so there's a couple other things I want to go through before saying farewell. But the first, before I forget, is the VNC view. Not the VNC view, the NDI view, this one. So we can see, this is what I was talking about before. Look at how many messages are here. I can scroll through these, and all of these are different messages that have been sent while the bus has been on. There's a bunch that have only been sent once, which is a little bit like, what message is only getting sent one time? So I don't know, I really want to get a proper, I want to get something where I can upload the DBC file so I can actually see what these messages are, because that'd be good. Cool. All right. So now let's talk about how I'm actually doing what you just saw. Got so many goddamn views. So much to manage. I really want like a screen where I can just see all of the views, because right now I'm changing views just with buttons on my little macro pad, and I always forget which one's which. So I really want a screen that I can just like, I want that one, I want that one. One day. Anyway. Cool. So yeah, I'm thinking of like how to best run this. I'll explain how I'm doing this right now in just a second. My thinking of how to do it the best is to send the full trajectory. So let me back up a bit. I'll explain how this is working right now first before what I want to move to. So the whole process here is that John has made a trajectory generator that creates a list, basically, of all of the different positions that we want the hand to be in throughout the profile of the throw and the catch. So this generator will, we put in things like how high we want it to throw, how much room the hand has to move, and stuff like that. and then this will generate, this will say, okay, well, if we want to throw this high, then, well, if we want to throw for this duration, then it will throw this high, and that means we need to reach this velocity, and it figures out what profile we need the hand to follow so that it will actually make the hand move fast enough to throw the ball as high as we want, and then it will wait for as long as it needs to before moving back down and catching the ball. And the way that the catching works is that it will move the hand down at a slightly lower speed than what we're expecting the ball to be coming in at, and that way the ball will contact it while the hand is moving, but the hand is moving slower than the ball should be moving at. So that way it will never overrun the ball and like reach the bottom before the ball does, and the ball should always hit it. And ideally the gains of the hand, like how loosely it's being controlled, will be set so that the ball can just push it down to continue it along its way. And so far that's working really well. I haven't actually tried any throws higher than a half a second height, like duration, partially because I only got this working last night, and yeah, I guess entirely because of that, and because I didn't want to break anything before today. As soon as I got it working, I'm like, okay, cool, this is enough for the live stream to show off what's going on, and then after the live stream I can push it a bit harder and see if anything breaks. Yeah, so this generator makes this trajectory, and then it will save it as a CSV file. The way that I'm currently using this right now is I have a ROS node that does this entire process, where it looks at it imports the CSV file, reads the file, gets the entire trajectory, and then sends that directly to the CAN bus. And this might seem a little bit odd, because I've spent a lot of time making a whole like CAN bus handler node, where this node is just responsible for all of the CAN bus stuff. But I did some testing with having a node for doing the trajectory stuff, which then sends to the CAN bus handler node, which then goes to the CAN bus and then out to the robot. And there's too much latency over between the topics. So I had the trajectory being sent out over a topic as fast as it possibly could, and there was weird latency. Like it was working on like the 100 hertz like frame rate for the trajectory, but much faster than that, and it doesn't really keep up. So what I've done instead is I've made a node that does the trajectory, and rather than sending that out over ROS, it just connects directly into the CAN bus. And this is cool because, for one thing, I didn't even know that I could have multiple nodes connected to the CAN bus at the same time. I've always just been operating under the assumption that only one can connect to the CAN bus at once. Don't really know why I thought that. I don't know, something about like when you have USBs plugged in, you can't have multiple devices accessing that USB at the same time. I thought it was something like that, but apparently not. But in any event, I don't really like this, because I don't like the fact that two things can connect to the CAN bus. That really, I don't know, it doesn't sit right with me. And a reflection of this is that if we look at the VNC view, we can see there's all of these errors, or warnings rather, saying that there's no handler command for this command. And this is because these commands are the ones that I'm using to set the trajectory of the hand. And so there's one node over here that's sending out these commands, that's like making the hand move. And then there's the main CAN bus handler node over here that's receiving these commands, being like, what the heck, what are these? I don't know what to do with these. These are random, like, these are strange commands. So either I can like set up in the handler node, I can say, hey, no, these commands are fine, just ignore them. Or ideally, I would only have one node connecting to the bus at any time. This right now is very much like a temporary measure, but there's no more permanent solution than a temporary one. So yeah, we'll see. So that's the general overview of what's going on right now. However, I have a thought of how to make it better, which is to use, so actually one problem with this is that it's not technically real time. So I have currently set up, I want to show you my code right now, just real quick. I thought I had it open, but apparently not. Oh. All right, just give me 1 sec. This one. Cool, so this is my code right now. Yeah, you can see it, hopefully. Make it a bit bigger. There is also a link to this in the description if you want to check it out yourself. But the way that this is working, yeah, here we go. This send trajectory thing we basically look at the trajectory has a timestamp when this point of the trajectory should be sent out, as well as a position, a velocity, and a torque. I don't want to get into the last three basically to control the hand. That's a separate topic. But the timestamp is particularly important. That's useful because I can use that to try to make sure that my messages are getting sent out exactly on that timestamp. So the way that I'm doing that is using a method suggested by Jean-Marc, who has also been extremely helpful on Zulip. And yeah, we can see what is going on here is we log the start time of when we are sending the command to run the trajectory. We look, that stuff doesn't really matter. At each step, we basically see, okay, how long has it been since we started the whole trajectory? And then how long do we need to wait right now until we are ready for the next step? Or until we're ready for this step. So we look at the time when this step should be sent out, and then we look at the time since we've started, and then we just wait for that amount of time. I'm using this custom sleep method that Jean-Marc suggested. He tested this out and got much more reliable timing with this versus just time.sleep. And yeah, so it seems pretty good. It's been working fine for me as far as I can tell. So I think that's quite good. Yeah, and then it just runs through the loop again. So then we look at the next time, we get everything that we need to, and then just before we send the messages out, we wait until right at the instant when we're supposed to be sending this out, and then it goes. However, there is, of course, latency between when these messages, when this like function runs, and when the message actually gets sent, and then when the message actually gets received. So there's a whole bunch of steps of latency in here. This send a message thing, as far as I'm aware, is quite fast, but I don't know how long it takes to get across the CAN bus. And that's kind of what I want to have the logger set up for, so that I can like see how quickly these things are coming through. And so far it has been kind of helpful, but I need the DBC file to know what the actual messages are. Yeah, it's also a little bit annoying because this is getting a little bit into the weeds, but when we're controlling the hand, to have as best control as we possibly can, which is what we want for something that is as precise as the hand needs to be, we are sending a position command, a velocity command, and a torque command. And I know I said I wouldn't get too far into this, and I'll try not to, but the general idea is we need to send those three. And thankfully, ODrive has the ability to do this. There is a single message type where you can say, I want this position, I want this velocity feed forward, and I want this torque feed forward. And you just put them all in and go. However, there's a limit to how fast, from memory, the limit is on the velocity, but there's a limit on how fast you can make the motor go when you're doing that. And that's a purely arbitrary limit that the ODrive people have just, I'm guessing that they just set it and then like, yep, cool, that should be enough for most applications, let's just leave it. And there's no way to change that. And so rather than sending one nice message that would actually show up in a DBC file, we have to send 3 custom messages that all have the same ID. So yeah, even with the DBC file, it's going to be kind of annoying because I can't time how often, I can't just look at the cycle time of this and say, yep, cool, that message is coming through 100 times a second, which for the current profile, that's what it's supposed to be. Instead, we'd have to take 1/3 of whatever that cycle time is, which is not a big issue, but it's just annoying, you know? Why can't things just be nice? Why can't they be easy? Once in this project, something will be easy. Anyway, yes, so that's what I'm currently doing, but it's not quite technically real time because there's that latency between like sending the commands out, and even though I'm using Jean-Marc's time sleep system, it still wouldn't be perfect. I haven't actually timed it because I don't really know the best way to do that, but I'm just assuming that it's not perfect. However, the Teensy, which I've already got set up, it's connected to the CAN bus, it's already there, is as close to real time as I can get right now with what I own. And so I'm thinking I can use the Teensy to send the trajectory commands. And the way that I'm thinking this will work is we have a lineup of throws that we want to make. And let's say that the next throw we want to make is a half a second throw, like the ones that you just saw. And before that trajectory needs to be run, we send that trajectory out over the CAN, through ROS, then through CAN, over to the Teensy. The Teensy will then store it. It will just hang on to it for a second, and it will just wait until the trajectory is supposed to start. Now, there's a little bit of an issue here, which is that the clock on the Teensy may not and probably won't be perfectly aligned with the clock on the Jetson, which is like the main computer that I'm using to run Juggabot. So I'm thinking, along with the trajectory that we're sending out, we can say, hey, this is the time right now, according to the Jetson, which is Juggabot's time. This is the time right now. This is the time when when this trajectory should start. And then the Teensy should just be able to say, okay, cool, even though my clock doesn't think that this is the time right now, I can look at the difference between these two and I can say, okay, yep, this is when I should be starting according to my Teensy time. I think that should work. And then it will step through and it will be able to send out those messages at a much more precise timing interval. Hopefully. We'll see. Yeah. So yeah, currently it's all in one ROS node. It's reading through the CSV, blah, blah, blah. Yeah, already gone through this. Yes, so lots of thoughts. One thing that's lurking in the back of my mind is that I know that the CAN bus can only support so many messages per second, and I am worried about upping the rate that the hand messages are going out at. Because right now, the profiles that you just saw, like the throwing that it was just doing, is at a 100 hertz sampling time throughout that trajectory, which means that the throw part and the catch part only have, I can't remember off the top of my head, but it was something like 10 to 15 sample points, like not very many points. It might even be fewer than that. So really, we want to have as fast of a sampling time as we possibly can on that hand control so that we can control it as precisely as possible. If we could control like 1,000 hertz, then we would have 100 plus spots, like positions that we'll be commanding the hand to be at. And that will give it a lot of control over where it should be. It will mean that the whole profile will be much tighter and it will be doing exactly what we wanted to do, which is good. But I don't want to overload the CAN bus. So we'll see how we go. All right, now let me have a drink of water. I need some. So I have some thoughts. I have lots of thoughts, but some in particular. I am feeling like we've reached a point where we can go full steam ahead for juggling. What I mean by this, I've got an analogy that I thought of last night, which is that it is very low puggle. Yeah, 100 hertz is, I should be able to go a lot higher, but the problem is that I'm sending so many other messages so the legs are all sending messages as well. And yeah, there's just a lot of messages. So I did some testing on this a while ago, and I was able to send about 5,500 messages per second in total over the CAN bus. And this was just like sending random nothing messages. In theory, it should be like 8,000, so I don't know why I have such a lower limit, but whatever. So 5,500 has become my like virtual ceiling. And currently, during just like when the robot is stationary, I mean, we can see here in my GUI, I have a CAN bus traffic element, and we can see that right at the end, when the robot was just stationary, it was just sitting there, we are at about 2,800. So this is with closed loop control of the legs as well. So this is the most that it will be for the legs moving. However, that only leaves like another, 2,000-ish for the hand, which I don't think 500 hertz control will be able to do. It should be able to do it if we can only send one message, but because we have to send 3 messages for every single spot, it really adds up how much is getting sent. Hopefully the ODrive people, I might actually ping the ODrive people to be like, hey, can you make these changes at some point? Because the changes that they need to make to allow us to do what we need to do is very, very minor. Oh, well, looking from the outside, it appears to be minor. So hopefully they can do that, but yeah, we'll see. But anyway, for the full steam ahead for juggling, I feel like, so I play this game, I like this game called Tricky Towers, where It's like Tetris, but tricky. And there's a version of this game where you're racing your opponents and you need to get all of your pieces down as fast as you can. And the first person to finish with all of the pieces down without dying is the winner. And you often reach this point in this game where you just slam the blocks, like this person in the middle is doing. They only have a few blocks left, so they can just drop them as fast as they can. And unless you die, that often works pretty well. And I'm feeling like we're at a point now where we can just slam the blocks. So we've had a lot of discussions on Zulip about how we can set up like a proper state machine to make Jugglebot a bit more of a mature robot system, so that I don't have to do things like homing it every single time I use it just because it doesn't remember that it's already been homed in this session. Things like that. Things like ease of living sorts of things that will make it actually a lot nicer to interact with the robot. But these things take a lot of time to set up, and I'm thinking I'm just going to leave that stuff for now. I'll still be like very, very, very interested in this stuff in theory, but I don't think I'll actually be implementing any of it on the robot for a little while. I really want to, it feels like it's at the point where we can just kind of hack together stuff and get it to work. So yeah, I'm thinking of being full steam ahead for juggling and just not really spending too much time on other things. However, but also, it might be worth, a big part of me is feeling like it might be worth revisiting the linear actuators. The only reason I say this is because I have recently gotten sponsorship offers from 2 branches of JLC PCB, or whatever I think JLC is like the parent company. But one of these is for hardware components, and the other one is for 3D manufacturing, like 3D printing and CNC and that sort of stuff. And I'm really thinking, if I do like a little bit of a redesign of the actuators, I don't want to do too much, but if I do a little bit of a redesign and I can get these made out of metal, that would remove a lot of my concerns about the precision and just the general jankiness of all of the actuators. However, I'm aware of the fact that if I make any little changes, I'm going to want to make a few. Like I want to change things, like for example, for these actuators, I have 3 pulleys routing each string. So one string goes up, one string goes down, or like one string pulls the leg up, one string pulls it down. I have 3 pulleys routing those strings around. They don't need to be 3, there only needs to be 2. I don't need that extra pulley there, I can just get rid of it. I want to change the carbon fiber push rods to be a metal rod, and that way I can use a linear bearing instead of this dodgy ass 6 like skateboard bearings basically that hold the push rod in place but not really very well. Yep. And a huge thing that I really am very, very interested in, which is a little bit separate to that, this is kind of like related but doesn't require as much work, is that I'm really hoping I can get those guys to manufacture the bellows. Anyone watching this live stream right now will be aware that I have had enormous trouble getting these bellows to print, and they just don't behave nicely. So I'm really wondering if I can just kind of like palm the problem off to someone else, and yeah, and just kind of click a button and then have them delivered to my home. So we'll see about that. Yeah. So I don't know. I think I'll probably just do like the linear actuator stuff on the side as I have time, as just like a side project. And then the main focus, like my day-to-day, will be on getting Jugglebot to throw well. But we'll see. It'd be so nice to have them made out of metal. It would be so, so cool. I imagine they will be so much more precise, so much better, so much more rugged. Yep. All right. I know that there was a lot of other things that I wanted to say, but I can't remember what they are right now. So that's that. I hope you found that interesting. I am very keen for what next week will bring. I want to make the first like proper attempt at juggling be on a live stream. Max, the bellows are for, let me show you on the robot. So, what camera are we on? Number 1. So down the bottom of all of the legs, we have Actually, let me show you on this camera. Oh, I've got to get up to change them. See, if I could do this on the remote, that'd be great. So down the bottom of all of the legs are these bellows. And what the purpose of these is to allow the leg to move around, like angle itself around, but it doesn't let the leg twist very much. Obviously I can twist it a little bit, but not a huge amount. And the reason for that is because I've got these cables that run from the actuators down to the O drives on the base, and I do not want those cables getting twisted around. So these motors that I have in the actuators have quite a bit of rotational inertia, and it's a bit touchy. They have quite a bit of rotational inertia, and when they accelerate or decelerate quickly, they have quite a bit of kick to make the actuator want to turn, and these bellows just stop that from happening. All of the ones that are on there right now, I printed a long time ago, like 6 months ago or something, and even at the time it was a bit of a hassle, but it just worked. Eventually it worked. But for some reason, I've been trying to print, like I've tried literally the exact same files, and it just doesn't work. The prints fail. So they get like part of the way through and they just fail. And I have many examples of failed bellows on my desk here that either don't print or do print, but don't collapse nicely. So yeah, not good. I tried one last week with just like one bellow. I just wanted to see what would happen. And I made this really interesting weaving pattern. This is supposed to just be a straight cone. So I don't really know what's going on there. I think that's kind of neat. But yeah, they are printed in TPU. And when they work, they're really cool. Like this was one of the first ones that I printed ages ago. It's super cool. You can get a lot of, I don't know, compression out of them. They're super, super cool when they work. But I just can't get them to print. Yeah. Well, or if I can get them to print, then they don't collapse properly. But hopefully the JLC 3DP people are more patient and have better print profiles than I do and can actually get it to work. Yeah, we'll see. All right, yeah, cool. So my next plan is my next steps are to recalibrate that inclinometer so that when the platform is supposed to be flat, it actually genuinely is flat, and it's not just the inclinometer that's flat. And my process for that is just going to be throw, okay, that was a little bit off this way. I'm going to tilt the robot back just a smidge, throw again, okay, that was a bit too much, and then, I don't know, just do that a bunch of times until I'm happy with it. It would be really good if I had a slow-mo camera, because as it is, it's very hard to tell what is going on. I can only really go off of the way that the ball like rocks once it's in the hand. So I don't think I'll be able to get it like perfectly precise, but it should be hopefully close enough. And then after that, I want to get it to throw at an angle, move and catch. And once it can do that, I will be satisfied with ticking off my next goal. So if anyone's been on my channel lately, you'll see I have, let me show you one here. I have Project Deep Blue Juggling goals. And one of the goals is to juggle one ball. And juggling one ball is a bit of a misnomer. You can't technically actually do that, but that's a separate topic. But as far as I'm concerned, that just means throw, move over, catch. I think throwing straight up and down is a bit lame. It doesn't involve the whole robot, so I'm not happy to call what we just saw juggling one ball. It has to be able to move. But yeah, so I want to make that the first attempt at that, well, the second attempt, I guess, because the first one was a couple of weeks ago. I want to make the next attempt be a live stream as well. So I'll either, depending on how things are going, I'll either wait until next week's Friday live stream, or I might just have a random live stream sometime next week, whenever I'm ready, and we'll see how it goes. So yeah, I guess keep an eye out for that if you're interested in watching it. Of course, I'll have the replay available so you can watch it later. But yeah, it should be fun. It should be exciting. So Max says, if you want to try and fix it yourself, you could ask on a 3D printing subreddit. Yeah. I've tried a lot of things. I think part of the problem is that once I get it to be printable, It doesn't work as a bellows anymore. So like all of the suggestions for making it printable, things like making the overhang less steep and like having maybe thicker walls and that sort of stuff, or like going in vase mode, whatever, which is what I've been doing. All that sort of stuff is very helpful for making the print succeed, but it's not helpful for making the thing do what I want it to do. And that geometry, I don't feel like I have a very good understanding of what actually makes it collapse. I've had some interesting suggestions, like Jean-Marc has suggested making the corners where it needs to fold be a little bit thinner than the kind of like mid spans. I really like that idea. I just need to actually sit down and model that and give it a test. But to be honest, my hopes aren't super high on that. I think it, I don't know, we'll see. Yeah. Puggle says, if you need to build another Jugglebot eventually, might as well build it right. Okay, yeah, that's an interesting point. So I'm extremely conflicted right now, to be honest, because I will definitely, unless I like die or something, I will be making another version of Jugglebot V5, and it will have a completely different form factor to this. I don't like this form factor at all anymore. I mean, it's cool, it's very cool, don't get me wrong, but it's not the best for what I want it to do. I am thinking of doing a Core XY style, like just a frame with a thing that, like a 3D printer almost, but it can't go up and down, it can just move X and Y, and then there's a hand in there that will do the throwing. Hopefully this will also be able to rotate as well, just around the two axes, but I don't even know if it will need to do that. I don't know, we'll see. But that's definitely in the works later. And so my plan up until these sponsorship offers came through was that I will get this version of Jugglebot working till it's good enough to be obviously cool. So probably 2 balls in one hand, I think would be that point. Or if it can juggle with me, or like and/or, something like that. And then I can make a Stuff Made Here style like edutainment video that doesn't, I don't know, something like a mix between what I've done in the past with my linear actuators and Stuff Made Here style. But like a big proper video being like, this is what I've done, this is how it works, blah, blah, blah. And then ditch this whole geometry and then start working on the Core XY or something different to this. There's John who, I don't need to introduce John anymore. John is pretty keen on a Delta style mechanism, and we've had a couple other suggestions come up here and there for very, very, very different geometries. And there's a lot of options on the table, so we'll see what I actually end up going with. But yeah, now that this offer has come through, I'm like, well, it would be a lot less work to remake this as it currently is with just metal parts, with slight redesigns here and there to make things a bit better. But also that would then push back other stuff a lot further. So I don't know, we'll see what I end up doing. It's a good problem to have, I suppose. I can't complain. So that's all right. Yes, all right. Cool, I think that's it. Stay tuned. I don't want to jinx myself, so I won't say anything about what will happen next week, but it should be fun. No matter what happens, unless something breaks, we should be in a pretty good spot for ticking this achievement off. Finally, 2 years almost after the last one. After we were able to throw a ball, we can finally catch a ball 2 years later. All right, cool. Hope you found that interesting, as always, and good luck with what you're doing, and I'll see you next week. Till then, have a good one.